And it saves you on insurance. And you should be able to take that paperwork into into the driving test, and they don't make you do the driving part, or shouldn't.
But you have to do the driving part. You don't have to do the braking part.
Okay. It must have changed since I did it, because I did driver's ed over the summer, took all the paperwork in, they looked through it, signed off, took my picture, and I was done.
Really?
Yep, because they did the written and driving test in the driver's ed.
Huh. Which we done like a certain amount of hours of driving.
Yeah. But different states, different procedures. Tennessee. All right, guys, so let's go on and look through the review sheet. We'll go on and look at 1 through 6. So to name the circle, it's just going to be circle
Is that
A.
because that's where the middle point where you start out everything, is that the reason it's named A?
Yeah, because a circle is a center in all the points that are a certain distance from that point. So radius is going to be from the center to a point on the circle. So we could say A, B, AD, or A, C.
You just have to have one middle.
So we need 2, because it says name.
Oh, yes.
Name 2. When you name 2 radius or radii, AB or BA would work, AD or DA would work, AC or AC would work. I'm going to tell you right now, if you put AB and BA, that's still only 1 radius. You just name the same line twice. I want 2 different ones. So AB or AD, those in either AB or BA, and then AD or DA, if you have both of those, that's fine. Just don't name the same line twice.
You don't want
So AB, AC would be fine. What I don't want, let's get an eraser, is you putting,
Oh, that makes sense.
yeah, no, AB, BA, that you just named 1 radius, you didn't name 2. I need 2. So you can use any 2 of these 3. Either way, flip it. Just don't name the same line twice. Most likely it'll be Thursday, because I don't think we'll finish this, especially with the late start. Name 2 chords. So a chord is just a line that connects 2 points on the circle. So CB is 1, and then EG.
That's called what?
Chord. What's the diameter? BC or CB. Because the diameter is a chord, it's the one that goes through the center. The diameter is the chord that goes through the center, and we consider it to be the biggest chord. It's going to be the longest chord that we can make, because any other spot is going to be a little bit smaller. Secant line, EH would work. And we have to have the line symbol above it. We could also have said EG.
I'm confused.
HG. Huh? It's a line that intersects the circle at 2 points. So we just need any line that cuts through the circle twice. So EG or EF, that line intersects the circle twice. So it's just a chord that's extended out. Any one of these 3 would work, or any iterations of them. So HE, GE, GH, any of those work. Now a tangent line intersects the circle at exactly 1 point. So JH, yes, or JI, HI, any of those work, and the point that it intersects it is I, because that's the point of tangency. Point of tangency is the point that it intersects the circle. Any other questions on 1 through 6? All right. Internally or externally tangent. Internally, tangent's the line that goes through between the two circles. Externally doesn't. So number 7 is? Number 8 is?
I figured that. Yeah.
So internally tangent, and it's really talking about the line that connects the two centers. Because if it crosses that line, then it's internal. If it doesn't cross that line, it is external. But in order for it to be able to cross that line, it's got to go between the two circles. So this one here doesn't, because the circles are inside of each other. Questions on internal or external? These ones here? Using Pythagorean Theorem. It's also nice if we know the Pythagorean triples. Because number 11, 5 would be the hypotenuse if this is a right triangle, which it gives us a 3, 4, 5, which is yes. Or we could say 3 squared plus 4 squared is equal to 5 squared. So 25 is equal to 5 squared is 25.
Okay.
Now, number 10, if you plugged it in as 65 squared is equal to 63 squared plus 16 squared, you would come out to a true statement. But this whole line is not just 16, it's 16 and, which gives us 32. So it shouldn't be 16, it should be 32. And because we could do 63 squared and then figure out what 32 squared is, write those down and add them together. Or I can just do 63 squared plus 32 squared in the calculator and hit enter. That works as well. Questions on this here? What should be the longest side for this here? 65. It should be, on all these here, it should be, all the ones on the test won't have, there won't be one like this here, but it should be going from the center to the point. Yes? It shouldn't be from the point to the side of the circle. That should not be the longest, or the radius shouldn't be the longest. Yeah. Well, the reason I'm saying that is if, say, this wasn't 25, this was 14, is there any way that's going to work? No, because that side has to be the biggest.
So that's why that is already.
Yeah, because what we're saying is that 15 squared plus 20 squared is supposed to equal 14 squared. There's no way that's going to work. But 9, as it is there, is yes. Any other questions on these here?
So what you were saying about 9?
Well,
Is it
this is yes.
yes?
If it had been 14 instead of 25, then it would have been no. Because there's no way that works.
And if this over here is no.
Yeah.
And no.
Mhm.
And
Yes. Mhm.
okay. Make it better.
Yeah, but I would definitely have the a squared plus b squared
Yeah, I
equals.
wrote that down. I wrote that down first.
Yeah, because it's based off them being a right triangle. 12 and 13, which one do we want to look at?
Yeah.
Because these two sides are going to be congruent. Yes, they're going to be equal to each other. So we're saying that 5x minus 14 equals 3x plus 10. Now we just need to solve for the value of x. I'm going to subtract 3x first. 5x minus 3x is minus 14 equals 2x is equal to, and last but not least, divide by 2, x is equal to 12. And that's all we have to do on this here. Questions on either one of these here? Set them equal to each other and solve, yep. Because they're going to be congruent. We can go on and look at this one here. These would be congruent as well. So 2x squared plus 4 is equal to 22. Well, the first thing we can do is subtract 4 from both sides, which will tell us that 2x squared is equal to, then we would divide by 2, telling us x squared is equal to 9. So we would square root both sides, and when we square root something, we're trying to see what times itself gives us 9, which would be? That would be. Now, we need to look back here because our only place where we have x is right here in squared, yes? So if I plugged it in, so say 2 times negative 3 squared plus 4, and this should give us 22, yes? What's negative 3 times negative 3? Because negative times a negative is a, which is positive 9 plus 4. 2 times 9 is 18 plus 4 is 22. Well, I know if it's positive, it's also going to get us to 22, so plus or minus is correct. Now, if it hadn't been squared, if this wasn't there, then we wouldn't use that plus or minus. But because back in the original spot, the only place where there's a square is, the only place where the variable is squared, we have the plus or minus. I'm going to skip ahead to this here to kind of reiterate this point to drive this home, because it's a little bit farther on here. This one here is going to be different. 53. I'm skipping ahead to drive home the point of the plus or minus. Here, to solve this one, and we can do this again tomorrow, the tangent squared is equal to the exterior times the whole. The tangent squared is equal to the exterior times the whole. So 53, whenever we have a tangent and a secant line, the tangent line squared is equal to the exterior of the secant times the whole thing. So 12 times 12 plus 15. Now, x squared is, well, just x squared. Here, well, 12 times 12 plus 15, I could type that whole thing in. It's all numbers. 324. And then we would square root both sides, which would give us x is equal to 18. Okay. And Riley, that was a pure guess. No, it's very rare that I get close to it. But here, what is the only spot we have a variable? Is just what? X, yes? Plus and minus. So positive or negative. Instead of writing 18 comma negative 18, we can write it as 1 plus or minus. But here, our length is what? Just x, yes? Can I have a negative length? No. So here, the answer is just 18. In the previous one, the variable was squared, wasn't it? Because it was x squared. That's why we could still have the positive or negative. Here, since it's just x. So here, we just have x, yes? So if I plug negative 18 in here, well, we would have a length of negative 18. I can't have that. So this here, it has to be positive. When I plug it back in, replace x with it. Now, if we go all the way back to the one we had before, getting closer, almost there, one more. Here, when I plugged the negative in, we ended up with what? A length of positive 22, yes? That's the difference. Because of that square, x squared is a part of the length of the line, we could have it be, x could be positive or negative. On the other one, the length was just x. We didn't have the square. Being squared takes care of the negative. It turns it back positive. So does that make sense in the difference? It's very, very subtle, but that's the only main difference. Okay? And most likely, these here, where we're just setting them equal and solving, we're not having to square or apply a square, is where we'll have the plus or minus if there's a square show up. If, on the other ones where we're squaring it as a part of the formula, then we won't need the plus or minus. Does that make sense? Sir? Yes. With this one?
Yeah. Thank you.
You're welcome. Now, once we get into, if you take Algebra 2 next year, a lot of the problems, the plus and minus is going to come every single time. Because for Algebra 2, we don't have an actual application for those problems. We're just talking in a theoretical sense. What is the solutions? So theoretically, x squared equals 9 is plus or minus 3 every single time. Here, we're applying it back to a length, so we have some restrictions on what lengths can be. Because for what times itself is 9? Well, 3 times 3 is 9. Yeah, it could be negative or positive. But when we apply it to an application of length, we can't have negative length. We need to see and make sure that it actually works in the problem itself. Any other questions on 14 or 15? (16, 17, or 16 through 21. We should definitely look at 20. Because Mariah did help me on this one. EDB is these three here. So we would be adding 51 and 39 in. Almost. Because 9 and 1 is 10. 5, 6, 7, 8, 9, 10, 11, 12, 130. So the measure of EDB is 130 degrees, which would be a minor arc. I'll take minor. I'll just take minor. The reason I emphasize this one, it's wrong on the answer key. I put 140. It should be 130. Because it's not quite a straight line. It's just slightly less than it. So if we did put a straight line in, it would be like this here. I definitely did specify on the test to make sure to say if there was a straight line. because it's just slightly under a straight line. Any other questions on 16 through 21? Yeah, get out of straight lines. Because it's doing the arcs and adding them together. So BA is the same as this, so it is 140, which is a minor arc. Minor arc is less than.
Add them all together. Subtract 36.
That's how I got 90. Yes. And then the central angles are same as their arcs, and then we can just add those arcs together. So EH would be 90. ADB, ADB. So from here to here, we can add 90, 51, 40, and 39 together to get that. Yep, or we can, since it's the only thing it's not is, we can subtract it from 140 and get 220 degrees, and this would be major because it's greater than 180. Yeah. Any other questions on this here?
And then any of it's under 180 is minor.
Yes. Okay. The congruent circles is not going to show up on the test. Determine if the two are congruent. So, yep, so 22, 23 aren't going to show up on the test. 24, so if two circles are congruent, and since the arcs are congruent, it's going to be 104. Because those two are going to have to be the same. So CFD would also be 120. Because if those two chords are the same, their arcs have to be the same as well. So if the chords are the same, the arcs have to be the same.
Your chord is
A, B, and CD. So if those are the same, these arc measures have to be the same as well.
how do you know that? Okay.
Yep. Yeah, that smart notebook.
Okay, so it's
Yeah.
So if the chords are the same, the arcs are the same?
Yep. And if the arcs are the same, the chords are the same. So it goes in either order. Do we want to look at 28 or 29?
29.
So whenever we have a diameter and a chord intersect at a right angle, the chord, that's not the diameter, is going to be cut in half. And the arcs are going to be congruent as well. So what that tells us is that y minus 5 is equal to 40. So I can solve this here by because we'll just add 5 to both sides and we get 45. Because y minus 5 is equal to 40, add 5, and we get our answer. Any questions on how we found the value of y? I get them flipped.
Oh, I looked the wrong Lily, that's why.
Yep. Oh yeah, because we're over here.
Oh, that makes sense.
Yep. Yeah, I don't quite have the space to sometimes put it underneath. So I just sometimes write it to the side. Yeah, so we're looking at 29. So any other questions on how we found y? Yeah, because writing below it means I lose the problem. Yeah, I'm on 39, 29, not 28.
I was confused. I was like, those numbers and those numbers don't match.
Yeah, no, it should be 39 and 15 because they just match up. Yeah. Yeah, otherwise I'm going to be writing down here and we lose it. You're good. Any other questions on how we found y for 29? Yes. Now x, our 4x minus 36 is going to equal our 2x plus 24 because those two segments are equal. Solve for the value of x. Don't want to erase. Well, there's different things we can do first because we could add 36 to both sides first, which will tell us that 4x is equal to 2x plus 16. Then we could minus 2x from both sides, telling us 2x is equal to, and lastly, divide both sides by 2. So x is 30 and y is 45. That's it. Questions on this here? Yeah. Yeah, because if we did that first, I can erase this here, we would get here, subtract 2x, which will tell us 2x minus 36 is equal to 24. And we get 2x equals. Yeah, whichever one we add or subtract first doesn't really matter. We could do it there. We save multiplication and division till the end because sometimes it doesn't divide out evenly. It makes it a little more complicated. Here it wouldn't be too bad. We could have divided by 2, telling us x minus 18 is equal to 12. Well, 12 plus 18 is still 30. It's recognizing as a point and a bigger touch. Or it recognizes my elbow. Because it'll recognize if I get too close as a different touch. Any other questions on this so far? So the radius we'll look at later. We'll look at it tomorrow, yes. We're going to look at 2 more. Brandy and Briley. Do y'all have questions on 32 or 33? Okay, we'll finish up with those 2 and then we'll look at the rest of it tomorrow. Because 32 is an inscribed angle. An inscribed angle is half the measure of its arc. Well, what's the measure of the arc? 164, yes?
So half of 164.
Mm-hmm. Yeah.
So, and then the arc would be times 37 times 2, which would be
7 times.
74.
Yep. Yeah. If it's a central angle, if this vertex is on the center, then the arc and the degree measure are the same. If it's on the circle, The inscribed angles have to measure the arc.
Is it always times 2?
Right, if we're going from the inscribed angle to the arc, it's times 2. If we're going from the arc to the inscribed angle, it's divided by 2. So if we're going from arc to angle, it's divided. If we're going from angle to arc, it's multiplied.